So I think we can get started. So thanks for all for coming here, listening to me. And so I'm Sauli Kiviranta from VTT, which is Technical Research Center of Finland. I have been working now a little over 5 years on virtual and augmented reality in the team which is mostly involved in human-machine systems. The team is called Human-Machine Interaction in Virtual Engineering. So we are dealing a lot with machine building industry and, for example, power plants, nuclear power plants, the ITER fusion reactor, what they are building in France to Cadarache. And I have been mostly involved in the commercial projects, what we have, implementation of VR and AR systems to the industry, but also in EU projects, mostly on the technical lead side, and I have been now acting 5 years as a lead developer in our VR lab. So we are today talking about augmented reality, but before we start, I will give a little bit about the background and context. I'm a system thinker, so we will be heavily relying on what we will be seeing on general system theory, and probably most importantly on cybernetics. So general system theory is a way of thinking of all the universal principles applying to the different kinds of systems at large. Is it the animal, is it the machine, is it the combination of the animal and machine, and what kind of things, what kind of analogies and similarities you see between those systems. And cybernetics is it actually initiated all the work like information theory, general system theory, and so on in the late 40s and 50s, and it's focused on control and communication in the animal and machine. And we will be taking a little bit deeper look at it later on. And I would say that most specific part of my work currently is within the human-machine systems. So considering human and machine as in a unity, you could say society and technology, and what kind of system they form where they are acting towards a common goal. You have some kind of a goal, some kind of a purpose for the man and the machine, and how they work together to achieve that goal. One interesting side is also knowledge engineering, knowledge creation. What does it mean? How does it work? And specifically transformation modalities in knowledge engineering. And last but not the least, the virtual and augmented reality, which is mostly on the side of means how we can utilize the technology in, for example, machine building and so on. And our definition currently, how we see virtual reality at large, is the use simulation of synthetic reality, that being the virtual model, and which is perceived and interacted in the same way as one interacts and perceives the real world. So just for you to keep in mind while this presentation is going on. So what is augmented reality? I think many have asked that question quite many times. What it is? It is superimposing graphical objects, it is using head-mounted displays, it is using 3D objects floating in the air, it is using markers, and it is using some screen computer displays, and it's real time, and it's semantic, and it's floating objects in the air, and it's like, it's a lot of things. Augmented reality is a lot of things. Wow. Amazing. I don't know what it is. Sorry guys. Today we will not be talking about what is augmented reality. But we can ask a question why it is. Why augmented reality has emerged. And for that, we will be focusing on 3 modalities. For the sake of convenience, let's talk about 3 modalities. I don't know what to call them. And first to start with the first modality. So how do we, as a human beings, obtain understanding of this world? We are making our observations since the day we are born to this world. We are making visual observation, we are listening, touching things, we are smelling things, and we are tasting things. You see all those little kids crawling on the floor, and they do taste everything. So let's assume that we are standing here on the Cyprus in a nice beach. We are standing on the beach. We are accompanied with our good friend doggy, with our good friend catfish, bat, and a butterfly. So we are standing on the beach and looking, oh my god, the scenery looks just awesome. And the doggy, just next to us, would be replying, yes, indeed, this beach smells awesome. Catfish would be saying, the beach tastes awesome. Why is it? For us, the visual sense is dominant. For dog, the smell olfactory sense is dominant. For the catfish, the surface of the catfish's outer surface is full of taste buds. And the dominant sense for the catfish is taste. For the bat, it would be saying, yeah, this beach just echoes awesomely. Because the echoing, what do you call this? Anyway, you got the point. Echoing is the dominant sense for bat. And the butterfly would be standing and saying that standing here tastes awesome. Because butterflies have taste buds in their feet. Okay, enough of that. For human, visual information is dominant. It is the dominant way how we perceive and understand this world. But please do not forget the other senses. Don't forget them. They are as important for some other creatures as vision is for us. So let's take a little look to the background of things. What happened 500 million years ago? Quite a while ago. First blob of living being started to develop light sensitivity. So vision starts to develop. They started to develop oral sensitivity. Audition starts to develop. 2 million years ago, oral signaling means that you were able to start producing sounds emerged. 400,000 years ago, modern eye, you could say that the eye, what we currently have, 400,000 years ago, it was on the same level. That's quite interesting. We have not talked anything yet except the fact that we can observe this world. This means that during this 500 million years, our brains develop ability to form concrete mental models, build understanding what is happening around us. And most importantly, in today's topics, we will be focusing on spatial reasoning. Which means, for example, you are standing in the middle of Africa somewhere, you hear something, you take a look at, you hear something and you start to, okay, it comes from that bush. Then you take a look at, do I see anything? You see gazelle. And gazelle starts to run, and you have to use your somatosensory system in conjunction with the movement, and you launch your arrow or you throw your spear. You cannot throw it directly at the target. You have to understand where it is at the point of impact, the gazelle, when you throw the javelin. So this is heavily related to the spatial reasoning side of your brain. So, our mental model, sense of relation, location, motion, distance, proximity, color, taste, smell, everything. You have sense that something is moving fast, you can feel, your sensory system is put to the limits. When you're visiting some amusement park, you smell things, you see things, and you come to a conclusion, something isn't right. Something in this picture isn't right. For example, this picture here. It's real city picture, and the only thing what has changed in that is focus. Focal plane is different from what you would observe normally. And your brains come to conclusion, okay, this has to be miniature model. Only your lens in your eye has changed position, and your brains make a conclusion, this has to be a miniature model. Or this picture here. Of course you know that the Leaning Tower of Pisa is not that small. This guy couldn't possibly be pushing it with his feet. But yet his brain, your brain, is now really struggling to understand what is going on in this picture. It looks, you see that it's leaning towards the tower, but you're not quite sure. Or when it comes to motion, you have a sequence of pictures, and suddenly your brain tells to you, okay, this has to be motion. There is, for example, neurological disease, which damages part of your brain, and suddenly you cannot perceive motion. You experience the world in exactly like before, but you simply cannot. When you pour coffee in a cup, it's like a still world, and you cannot make judgment when is this cup going to be full of coffee, and you pour it over the table. Sounds crazy, but that's how our brains work on this concrete reasoning side. Okay, let's proceed. So, what did we learn? We have 5 main senses to obtain feedback, observe this world. Our mental models are heavily based on the inference between these models. That's 500 million years of evolution, could be somehow useful. Learning. Our mental models are composed of this data. Sensations we experience form our perception. For example, if you look at this box, are you looking at it from downwards or upwards? Sometimes you look at it and you're looking downwards. Or this, is it a duck or is it a rabbit? Sometimes it looks like it's a little bit rabbit and sometimes it looks like a little bit duck. Or this, is it a base or faces? Those kind of things are going on constantly in your brain when you are walking around and experiencing this world. So that's the modality 1, 500 million years, concrete reasoning. What is modality 2? I think we have to continue our timeline to see what is going on. 100,000 years ago, about, it's not well known, verbal language, oral, grammatical communication started to emerge. That the fact that you can communicate, establish sentences and describe to your fellow hunter what is going on. Yesterday I went hunting and did this and that and so on. Only 100,000 years ago. There was some other events. For example, 37,000 years ago we started to learn how to count things. Numbers emerged. Le Bonbon is like counting, for example, for apparently lunar phase tracking. Proto-writing, only 7,000 years ago we were able to start scrambling something on the walls to pass the message to the next generation. Textual writing, that we can actually use meaningful sentences and write them down. That's quite interesting when you think about the previous one. So, during this time our brains really took giant leaps on abstract reasoning. Abstract reasoning that for the purpose of communication and for the purpose of abstracting abstractions. So, when we see someone running, we could be telling to our friend, okay, the gazelle was running like this, or you could try to describe how some flower smells, you could try to describe some scenery, how it looked like when you were experiencing it. You have in your concrete reasoning mental models, you have the references for whatever you start to describe. When your mother was teaching you when you were born, who is father, who is mother, this is what is going on. You have a reference which is described by the abstract language what we have. Reference, communication, syntax, grammar, denotation, abstractions of abstractions. So, what did we learn? Human, 100,000 years ago, started to be able to heavily use abstractions. As social creature, we got the insane advantage from this glitch. Some say that it was just some random mutation in our brain and suddenly we were able to communicate with our fellow beings. And these abstractions enable us to communicate concrete events to our fellow beings, but pay attention, this, as soon as we say it's a box, we have lost something. As soon as we go to tell a friend, yeah, there was this box, you have lost the connection between your concrete reasoning where you can interpret the box in many ways. If you are hydraulic engineer, you will be seeing some machine in a completely different way than ergonomics person would be, for example, seeing. So the modality 2, abstract reasoning. Now, before we continue to the third modality, we will have to take a little bit closer look about these two things. So let's return to the timeline. 600 years ago, time flies when you're having fun. 600 years ago, Filippo Brunelleschi invented technology called perspective drawing. You mentioned it yesterday. What does it mean? Brunelleschi figured out that he found out the technique how to draw things in the same way how the human observes things. You stand in front of a building. Prior to this time, it was only the outer lines. really, really flat, and the proportions of everything in the paintings and art was completely off, because people simply didn't know how to draw in right spatial way. And Brunelleschi invented a way how to do it. So, for proving to his fellow scientist, artist, how does his new perspective realism work, he had to figure out a way. He built a device, and he wanted to prove this perspective drawing according to the Euclidean laws of geometric optics. So he had a drawing, and he had a mirror, and he made an experiment where you need to look through the painting in front of the building. Now, you go about and you say that, have we actually seen this before? Looks mighty familiar setting. Oh, here we have, obviously, visualization of factory under construction in 2010. And here on the right, we have visualization of baptistery by Brunelleschi in 1430. That's quite an interesting coincidence. So what Brunelleschi actually did, he created the baseline where we can start to draw things in a way that when you stand at a specific position, consider it as you know the position of the person who is observing things. Now when you think about augmented reality sense, you have tracking. Okay, it's not mighty dynamic, but still you need to know the position of the user, and while he's observing your painting or art, things just suddenly become so much more real. So, for example, take a video of Johnny Lee, who is very famous for introducing head tracking to the wider masses. What is actually happening in the videos is that when Johnny Lee is showing you a video of tracked camera, you see it in perfect 3D. Why is that? You don't need any 3D glasses. It's a flat 2D surface what you are using, but it triggers in your brain that the parallax change in the picture is perfect, and suddenly your brain say, oh wow, those objects are actually in 3D. There goes the concrete reasoning in action. So within 50 years, military side starts to get involved heavily on things, and they build something that is called heads-up display, meaning that the pilot can keep his head up while he's in the cockpit, and he doesn't have to look down to the meters. And this means that they were able to position graphical objects which are physically correct no matter what position you look at it. Okay, it's not exactly head tracking, but it's a optical way of making sure that the objects are at infinite distance by focus, which makes you perceive them as they were tied to the physical construct of the plane or gun. In 1990, someone coins the term augmented reality. That's Thomas Caudle, Boeing, 1990. Caudle had an interesting publication where he was depicting a device, what you can look through, head-mounted device. Head-mounted displays were created a long time ago, but he still considered the first to depict the combination of concrete and abstract reasoning. Of course, this was already shown to a wider audience in Terminator in 1984. But someone who put it all together and made some sense out of it was Caudle in 19. So what did we learn? Perspective drawing invented by Brunelleschi 600 years ago. For the first time, spatial reasoning could be unleashed for the purpose of art and engineering. So finally, the engineers, designers, architects could be designing buildings that if you stand in a specific spot in a building, the whole construct forms, for example, all the straight lines that you have in the building point directly to the altar. Or painters, when you stand at a specific spot, at a specific distance from the painting, it suddenly becomes so much more real because the perspective is correct. So let's take a little bit of theoretical detour at this point. I mentioned cybernetics a little bit earlier. So cybernetics is mostly concerned about the control and communication in the animal and machine. So it can be squeezed saying that you have to have a closed loop, you have to have a feedback. that the system, is it human or machine, which observes the world, it has to, this observation is form of feedback. And one of the, well, the main author is Norbert Wiener, published the book Cybernetics, Control and Communication and Animal and Machine, 1948. It's worthwhile to check out. I will not explain too much about it. But when we take a cybernetic view on the human and start to think about augmented reality, what does this feedback actually mean for us? The researchers are saying that in the machine side, feedback is really, really critical. You cannot have any kind of learning without feedback. It doesn't mean feedback that someone comes and taps to your back and says, well done. It means feedback that you receive something from what you are doing. You make an observation. Of course, it's those 5 senses that we have in our case for our system, which is used as a feedback and compared to the reference, have we successfully done something or not. And when we take a control theory view, sorry for being a little bit deep in this, we have a mental model where we have some kind of a reference. We will proceed in the action of drinking coffee. Our mental model provides us with the reference, and the controller, being our brain, operates our actuator in order to manipulate the object, here being the hand trying to grab the coffee cup. And now through your senses, you constantly, it's a infinite amount of trials and errors when you start to reach and you perform it a million times in your life, and you learn through this, and you do it better and better. But it's only possible by the sensory feedback that have you achieved your goal. And then finally, when the reference in respect to feedback goes to 0, you have achieved your goal. So that's the end of the theoretical bit. So what could we be doing with this feedback? So we have these 5 senses. We can utilize it for feedback, hence for learning. Let's take a look. So on the visual feedback side, now we are looking only at the individual senses. We ignore all the other senses when we are looking. We can think about concrete reasoning side, overlaying 3D object. For example, this puppy here. It's already so realistic that if I actually replaced with the real glass puppy, and I put marker under it, you all could probably go, that's augmented reality, that's just augmented puppy there. But probably you couldn't tell. Also these street paintings or some kind of games what people have been visiting, these are the side of visual feedback where you relate to the concrete reasoning side. Now if you go to the activity of actually trying to communicate to your subject, be it human or whatever, there you want to pass information. Well, we could talk about entropy and all that for God knows how long time, but the main idea is that the abstract reasoning side is heavily for the purpose of communication, abstract information. That you have problem somewhere and you slap a sticker on it, and the person who sees the sticker has to have in his mental model reference that this probably means it's somehow dangerous. Now when we proceed, remember, we are sense by sense. You could think this as an augmentation of oral side. You have an audio book. You press a button and horse sound comes from it. Okay, the direction is probably not right, but the perception is that, okay, there, you are standing now, like now, and children behind you presses the button and you go about, okay, where's the horse? That's the concrete reasoning side. And if you want to really have a very interesting experience, you can go to YouTube and check the virtual barber shop. Put headset on, close your eyes, sit at your desk, and listen through this. It's amazing. I promise you, you want to check this out. But now when we think about abstract reasoning side, for example, this truck, when it's reversing, and there are many cases where people simply do not notice visually, they have to add information. They have to add abstract information of beeping, which is trusted that the person, if it was a jungle guy, he wouldn't probably understand what his abstract meaning is. But normal citizen would be saying that, okay, there's some problem somewhere around. Same goes for fire trucks, waking up in the morning and so on. Touch feedback. We have a lot of nice and fancy kind of gadgets for making you feel as if you were holding, for example, cup, whereas marble without marble. You could be thinking about using some motion platform, even when you think about children holding a weapon in their hand. Fake weapon. The haptic feedback, if it was metal fake weapon, you close your eyes and you are given a gun, it might feel real for you. But when we think about the abstract side, you can have a mobile phone which is trying to communicate you, someone is calling, it's buzzing in against your light. That's your somatosensory system, use it as a feedback channel to tell you the phone is ringing. Or when you think about blind people and the way they are writing, you are observing visually the writing, but they are observing it through their fingertips. That's another way of communicating abstract information to the human. Smell feedback, okay, now we're getting it's getting a little bit tricky. Let's imagine this crazy scientist puts some kind of odor machine in the toilet and he wants to deliver you the feeling that when you close your eyes you are perfectly in some flowery field. At least that's what he tries to do. And even on the gaming side there seems to be some kind of machines which like yours, maybe they make you smell like fish or something, but they're attempting to use your smell feedback to make you feel like you're fishing or you're running in the field. And what about the abstract reasoning side? That was a little bit tricky to find, but when you think about someone passing information for you, I get a nice example from France, because in Finland we don't use gas at all. So the problem with the propane as a source of energy is that it doesn't smell anything, and it's mighty dangerous. So what they first did, they introduced the smell of vanilla to the propane. And of course, like their intention was, I want to pass information that there's something dangerous. And people go, oh, awesome, vanilla, someone's cooking something and so on. And it was a trouble. So they had to change the component of information in the propane to be ethanethiol, which is extremely nasty smell. And as soon as you smell it, you immediately go, okay, something is wrong, something is dangerous here. So that is transferring abstract information through the smell feedback to the human. Taste feedback, again the same crazy scientist is trying to make you, when you take a drink of this can, that okay, that this is something which is peach, or you take a candy and oh yes, strawberries, that's simply awesome. But when we think about the abstract side of things, I had to find an example from USA. Prohibition time. The government had the problem, they want to heavily taxate alcohol, but they had the problem that industry was using alcohol a lot, and it was like available in vast quantities. And again, they wanted to pass information to the people, don't drink this has been not taxed. And they add poison to the alcohol, and people start to die. Okay, you have delivered your information, you wanted to pass information, but people start to die. Not exactly the best way. So what they ended up doing, actually adding denatonium. You have heard denatured alcohol, which is again, when you drink the industrial alcohol, it's same alcohol, but there's denatonium in it, which makes it taste horrible. You start to vomit and do any crazy kind of things. So someone wants to pass you abstract information, do not drink this. And now I have to give notification. When people are talking to you about augmented reality and they talk to you about mixed reality continuum, they are talking about the concrete reasoning side of things. They are not talking about Google Glass where you can browse Wikipedia. They are talking about tapping into spatial temporal reasoning. Spatial meaning that you observe something is how far, and if it has a motion, the temporal side. So keep this in mind and do not get confused with benefits of modeling and simulation with the benefits of what is called virtual and augmented reality. Those are two distinct things. So what did we learn? Cybernetics, concept of closed loop systems with feedback, be it human or machine, the feedback enables you to learn. Concrete reasoning side acts as a reference. Abstract reasoning side emerges for the purpose of communication. Of course you can abstract the abstractions and have a mental model of those, but that was the baseline. And there's an interesting similarity in organizational knowledge creation side. If you are familiar with the works of Ikuhiro Nonaka, 1994, very influential article, you may want to read it, Nonaka, 94, and the knowledge transformation modalities. So finally, we have many combinatory ways to utilize the senses for learning. So it's, even if we have this nice old school way of reading text and so on, we can imagine a lot of different kind of combinations, how we communicate the concrete side how we communicate the abstract side. Visual sense is dominant, but don't forget the other senses. We have a lot of people already with some deficits who are using the other senses perfectly for learning and so on. So we covered the two sides of concrete and abstract reason. So let's check the third side, third modality. And before that we have to take another theory detour. If you remember what I talked about human-machine system, unity of human and machine working towards a common goal. All this is heavily based on cybernetics and system theory. Ludwig von Bertalanffy published the system theory 68, and prior to that, Wiener published in 48. They were both participating, just as the Ashby and another big players were participating in the Macy conferences in cybernetics. So they all have very, very strong connection to the Wiener's work on cybernetics. And in respect to the human-machine system, there's very interesting work that has been done in the Russian side, originally by Leontev on
Open University book, by the way. That
okay,
was
nice.
from a conference at the OU.
I cannot see who are the authors.
Yeah,
Yes, it's Engelstern. Leontev originally on the Russian side, so the Russian school of activity theory, and Yrjö Engström is Finn on the Nordic school of activity theory. Activity theory gives you a very good structure when you are trying to think, for example, activities what are happening in the industrial context. So, in respect to the general system theory, we have a system which is acting within the system boundary, and everything outside of that is considered surrounding. We have human, from cybernetic sense with the feedback loop, and then we have the other system which is now being machine, and the machine with the feedback loop. When we put these two together, we form a bigger system which we now call human-machine system, and from the cybernetic point of view, it's the unity of the human and machine with the feedback. We can see Wright brothers, that's a human-machine system where most of the physical properties are from the machine, where the control is from the human. You have, Man, crazy guy who has been doing a lot of sensory augmentation for like 30 years, has license to equip all this wherever he goes. Räikkönen, rally driving, yet another human-machine system, where a lot of the functions of control are put to the human. In DTP2, I talk about ITER fusion reactor. They have a problem that within the fusion reactor, you cannot go inside. So they have to go inside with robots. But all of the tasks are such, well not all, but most of the tasks are such that they have to be operated by the human. The human have to have view to the fusion reactor through the sensory technical sensors. So again, when we take a control theory view, the system has changed, so we are now talking about human-machine system. We have a goal, which is again in your mental model, you have some kind of idea, how can I drill a hole? Use it as a reference for you. Your brain operates your actuator, operating the objects, here being the drill, holding your hand, and the blanket. And you make an observation. Okay, did I succeed? No. You go around, and as soon as you have successful image that you have achieved your goal, you are happy. You have achieved your goal. So, what is this feedback side? What is going on in the feedback side now when we talk about human-machine systems? We have these sensors on human, but on the machine side, what is going on? Wow. That's a lot of sensors. How in the world are we going to transform all this information, this sensory information, the databases, the collective knowledge of mankind? How are we going to transform these to be compatible with our abstract and concrete reasoning? That's quite a big of a challenge. So we are really concerned about this point. What kind of combination of abstract and concrete reasoning can we form that the understanding of the information that we have available is most easily observable? The human can learn in the best possible way what is going on around him. And now remember that it's not only about sensing. The transformation of this information to the five senses to be compatible with our mental model. You can talk about contextualization, knowing where you are, what you are doing, data acquisition, what kind of databases you have available, transformation from the sensors. You cannot see Röntgen, X-rays, you cannot see ultraviolet, how to transform that into a way that the human can sense it. You cannot see airflows. For example, we have had a lot of discussion about companies who need to visualize to their engineers. How do the airflows go? They don't know where to put the coffee cup holder in the cabin of the machine because they cannot observe. Sure, they can simulate, and then we can visualize the information. Okay, in your cabin with augmented reality, it goes like that. I don't put my coffee cup holder there. That is transformation to the concrete reasoning side of things from abstract model. And also you can think about how you utilize the processing power you have in your smartphones and so on to remove the laborious and mind-numbing tasks from the human to get understanding of some specific situation. Let's take a couple of examples. Now we are mostly talking about the abstract reasoning side. We have a device, machine, solar impulse, which is purely powered by solar power, and you have an operator, the driver in the cabin. And they have inclination meters, and the problem with this machine is that if you incline it more than 5 degrees, the plane will be destroyed. So of course you can visually try to provide that. But when it's risk of destroying the whole system and potentially killing the man, you want to do something else. So as soon as the inclination starts to approach, let's say 4 degrees, they have a haptic device, touch device, somatosensory device, whatever you want to call it, which starts to buzz your hand. You mind your business, you're observing something, and suddenly it starts to buzz. The system is telling you, watch out, you are about to approach the limit. And same can be said, for example, for International Space Station. They don't have any up or down or this kind of things, because you can float in the space. So in the same way, you could try to, if it's needed, first of all, if it's needed, you could try to provide different, if there's no visual clues of which is up or down, you can try to provide some kind of a sensory input for the man, what is the direction. Now, again, continuing on the abstract side, of course we have a formula, not anymore Ferrari, but on trajectory, but anyway. There was a study published some time ago that people who are in the wheelchair, they do not consciously think about it, but subconsciously the brain accepts the machine as the extension, as a part of their body. How they behave, how they control. The brain has accepted the machine part as part of their body. So what could we be thinking about doing? For example, we have these nice devices. I visited Laval Virtual a couple of years ago, and there was this, I think some Japanese guys or so on who had made some tactile simulation. You can use microphone to measure some fabric, and then you can feel a virtual object being that fabric. What if we use the same kind of communication channel, put strain gauges in the wheels, get the slipperiness of each wheel and transfer it as a feedback to the user? Sooner or later, the driver would be starting to, the brains would be adapting and starting to get the feeling of how slippery each wheel is, and probably greatly increasing the possibility of driving with the machine. And here's a very interesting example from the concrete reasoning side. This soldier, Lance Corporal Landberg, in the war he lost his eyes. No vision anymore. What did the scientists do with him? They put a camera at the same point where he would be seeing, and they connected the camera to the tongue. Now that's interesting. And what is going on in the Landberg's brain? Landberg is able to see through his tongue. Through the somatosensory system, he is able to form visual image of the surrounding. That's interesting. Let's say another example. For example, Fukushima. You have some firemen who have to go there, do some tasks, save someone or whatever. You have sensors which are able to sense the radioactivity. Human cannot sense it. Do you want to show it as a meter, as an abstract form, or would it be more interesting to visualize it in the concrete side, concrete reasoning side? Do not step on the red areas, walk just here against the wall and so on. Of course you can combine the abstract side of things if it's useful in the situation. But just something for you to think. We have combination of concrete reasoning and abstract reasoning in a useful way. So what did we learn? Human-machine system is the unity of society and technology. If you are interested, check this out. We have vast amount of sensors and data available. Technology can be used to enhance our perception, enables us to see things what we can naturally see. But when you visualize or try to provide the feedback, keep in mind the two modalities. Our brain is extremely plastic. It has adapted and it will adapt. So that's our three modalities. Now, when we come to actually thinking about learning, how could we utilize all this? How could we utilize this to teach difficult subject? So you have to ask yourself questions like, what is the cognitive process? What is the cognitive problem? If you're showing to your students some physics study and so on, is there something abstract missing? What is not? They simply do not understand the connection of the formula of what is actually happening. Think about that and try to see what could you be bringing as a feedback so the gap is filled. Divide and conquer. Try to see what is the missing link in the abstract side or concrete side. What phenomenon is not perceivable? If you are talking about gravity, you cannot sense it, you cannot see it. If you are doing some physics experiment with gravity, try to see if you can use Google Glass or whatever to show something which is more meaningful for the students. So, these cognitive limits, what you are trying to overcome. When we think about from cybernetic point of view, if you exceed the cognitive limits, I talk about apparent cognitive limits because we are not fully utilizing our senses at all so far. So what we see, we have problems like you can pay attention to 4 objects at one time. Have you seen the YouTube video, for example, where you have basketball players and suddenly gorilla passes by? You are asked to pay attention to the players and you don't see at all that there's a gorilla in between. And then later on you say, oh my God, how could I miss that? Your cognitive limit of attention was exceeded there, and this gorilla never existed in your mental model in the first place. So you have to pay attention to those things. Do you want to put blobs of augmented reality all over your visual field? Probably not. Little bit of information theory. I talked to some of people about this a couple of days ago. They figured out that in the optical communication, they have Google, for example, is pushing out their 1 gigabit network. And suddenly someone goes about, okay, we have this way of removing noise in the acoustics by subtracting error from 2 signals. And suddenly they could use optical channel from 1 gigabit to 400 gigabits. They did the test a couple of days ago over the ocean and boosted from 1 gigabit to 4 gigabit. Same channel, 400 times bigger information capacity. We could be thinking about similar kind of things. What are we actually, when we scribble those symbols on the walls and use mostly our visual sense, are we actually utilizing, is it cognitive limitation or is it just the improper use of the channels? Are we fully utilizing our capabilities? We have some big looming nervous like monsters coming around, big data. A lot of people are talking about evaluation, analysis, and so on. We have this data revolution, Google stores all the information. That's quite problematic. The technology is going on and we have not in any way, in any meaningful way, improved our ability to build understanding. We are still reading our books. We are still watching some videos on YouTube. We are still being told by our older mentors how things are working. Same goes about Internet of Things. Everything is telling something to something and so on. That's crazy complicated. Are we prepared with our means of communication to all of this? I think we are in dire need for new ways of learning, and we have to stop fussing about this data and no information. Knowledge is nothing about data. Knowledge is nothing about information. So small last detour, food for thought. Joshua Fowler. This guy, just average guy, journalist, minding his business, and gets an assignment. Do a story about memory championship. It's a competition where crazy people go about and memorize 1,000 sequence of pi, or like in 15 seconds order of deck of cards and so on. And Joshua goes and tries to make a story of these guys. And he interviews a couple of the guys, quite many apparently, and figures out, wait a minute, these guys are not exceptional in any way. They have just same kind of techniques what they use to memorize these abstract things. And the most common of these is the method of logic, method of memory plays, which relies on memorizing spatial relationships and establishing order of abstract things and recollect the abstract things which are attached to your concrete mental model. You have a lot of different kind of examples of this, remembering some axis systems or remembering the days and so on. So you don't have to be some kind of prodigy, child prodigy or anything to be able to do that. It is just about combining in a smart way, the concrete reasoning side with the abstract reasoning side. Now we can ask, how could we utilize this for learning? Be it walking around the streets trying to learn French and French words or whatever formula you are trying to appear in your physical world. I don't know, just a food for thought for you. Do we have to be child prodigy, or can we somehow use the technology to combine these and learn in a new way? Another example, Bruce Chatwin, author, decides to go about and go to Australia and make some kind of a book. And he figures out that the Aboriginals or Australian indigenous, I don't know how to call them, they have these things called songlines, where they are relying on rhythm and abstract sequence of words called songs, obviously, for the purpose of recollecting spatial places, how to go across a desert and so on. And they could travel through thousands of kilometers or hundreds of kilometers by just singing the path. So this is very interesting. On the first example of Joshua Fowler, we had concrete reasoning utilized for abstract memorizing things, and here we have something on the abstract side also combined with the concrete side, and it gives you an insane capacity of traveling in space. And there was actually a funny example of this, that one bus driver with this author, they were traveling, and one Aboriginal was sitting in the bus, and he was singing. As they were driving, he was singing, and he was singing faster and faster and faster, and he was really sweating and struggling and singing, and then they realized, like, slow down a little bit, because this guy is so used to be singing while he's traveling that he has to memorize, go through the path, and the bus driver was driving so fast that he was really struggling to keep up with the singing. That's not nice. So that's end of the detours. There could be some big things that we can achieve by combining at least these two and utilizing technology. So what did we learn? We learned about concrete reasoning, abstract reasoning, and I call it transformational reasoning, the third modality. We can come up, you can say it's augmented reality or whatever, but I feel this is for the time being okay. So feedback respecting your mental models, what you have learned, how you have learned, for example, there's a scientific study which says that as soon as you hear a word strawberry, any word, your brain lives through every single experience you have had regarding strawberries. Wow. Someone tells you, Mom, your brains go about and, in a split of a second, live through all the experience what you have about your mom. That's interesting things happening. Our mindset in teaching is really falling behind in dramatic pace of what is happening on the technology side. We really have to break our mindset and find new ways how to do things, how to learn, how to visualize things, how to get understanding of some complex things like black hole simulation and so on. And we have to realize that our brain is very plastic, and it can adapt to new crazy ways of learning. So finally, what is augmented reality? What is it? Is it about these blobs? I don't know. I don't know what is augmented reality. It has huge potential. That I sense. But it's very elusive and in my opinion not really understood well so far. So, thank you.
Actually,
So,
completely different question. Technically, it looks to me like we're currently undergoing a generation change in the devices that will be available from this CRT mirror technology to the LED wave thingy, the hologram-like looking ones.
yes.
Surely tell us more about that.
It looks like now we are really, well, you have all those gadgets and devices like Oculus Rifts and Google Glasses and all things are so the world starts to be ready. We have done a lot of development over like 30, 40, 50 years on the technology side, on the machine side and so on. Now these perceptual devices, whatever you call it, you can call iPad or head-mounted display or whatever, they are really starting to catch up that we could be thinking about doing some things like this. So it starts to be the right. I don't know if I properly understood your question, but
yeah, I was more interested in the technological change. Recently went to see Vuzix, who have an office in where I live in Oxford, and the stuff they showed around were basically the old set-mounted displays where you have a little CRT LCD display in your glass, which looks like 1980. And they also have a mobile version like the Google Glasses, which then uses the trick of mirror things, I guess. But the next thing they're currently building as a research prototype, that was something I found very, very thrilling. It's basically little lines in your glasses with a sensitive area into which you really project light beams into it. So it flexes a bit like a hologram when you look through it, but it's a completely different technology compared to the pixel-oriented.
yes. So what's happening, for example, with Google Glass? It's just another. If you take your phone and you have a string of metal here, and you attach your phone floating in the air while you're walking. That's what we have with the Google Glass. It's not really tapping into the concrete reasoning side. It is just a display which is always with you, where you can show some mostly abstract information for the user. And here is a critical point why it's useful. You can start to use in the context of working or learning something. You can use techniques like priming or whatever to show the user feedback. Feedback is very important. That when you're doing something, you get immediately feedback. Behavioral scientists would be going crazy about it, but you can immediately provide feedback. Did you do it right? Did you do it wrong? Or provide information exactly at the point when things are happening. For example, in one case, industrial case where I was working is in respect to welding. Welding is a really apparently simple task where you just push the button and start doing, but on the background it's very, very complicated thing. And it's very hard for the welder to understand what is actually happening in the process. Why am I not succeeding? Is it because of the position or is it because of the setting? And this information never comes to the user. So what we did, we built a head-mounted display system with the welding mask where they actually can get on the fly constantly the information, what is actually, so they can a lot easier associate what is the thing that they're doing wrong currently. So this kind of things what you can imagine doing with devices like Google Glass where you can provide visual information. It doesn't have to be visual, as we discussed. It could be oral feedback, it could be touch, it could be vibrating gun and telling you something and so on. It just happens that Google made this device. Now what you talk about is glasses where you can actually engulf, like Oculus Rift, that the user whole field of view is engulfed in the virtual scene. Then we can start to think about the concrete reasoning side, where we can start putting objects where they were not, like historical visiting side, and how did it...
But there's still a technical barrier, right? Are there any modes?
Currently, the technology like Oculus Rift, you can engulf the whole field of view. The resolution limit is really, really primitive. You have some like Epson Moverio, I think it was Epson Moverio, where you have optical see-through, so you can have pretty much your whole field of view as a display surface, and you can see through it. So you can, but there's a lot of technical challenges on this. How you can actually put them in. You can show, for example, okay, you have to go this direction, but if I have to place an arrow on top of this bottle, please drink water or you get dehydrated. Those kind of things, to get them in this precise level is very challenging for the time being. One trick what you can do is you can use sensory transformation, that you use camera to provide that the view. But I think we saw yesterday the video from you where by using cameras they put you into other place. But you can put the cameras just near to your current eye location, which does the trick for you, that the pixel-to-pixel mapping of the visual content and your virtual content will be right. So that's a quick workaround how to solve this problem of placing objects in close vicinity in the right place. But that's not the only thing what you want to do, because, for example, human beings, we can see in 3D, let's say like 100 meters properly, which is because of our eye distance is such that anything behind certain limit is just flat. There's absolutely no visual cues for you to understand, is it 1 kilometer away or is it 10 kilometers away. Now when you are walking in Italy and you're seeing the mountains and you go, well, okay, that's 5 kilometers away. And some local comes and tells you, no, it's 40 kilometers away. That you could use the technology to show you, okay, this is actually 40 kilometers away. For example, let's say a construction worker, they have all their rulers and so on. And if you constantly provided the worker with the feedback of distances in this concrete reasoning side, sooner or later they would start to have a very precise understanding that this distance is actually 90 centimeters, 25 millimeters, and so on. Just because currently they don't have any feedback, they cannot learn it. They can do it every now and then and have distances, but as soon as you start to utilize technology for giving you more accurate feedback, your concrete reasoning model with the abstract reasoning model starts to get a lot more powerful. And you start to, just the fact that you don't have the feedback is greatly limiting your understanding of this world. Any other questions?
I have a question. Thanks for a great presentation. It's very interesting. So it seems like current approaches are focusing on providing feedback using like existing sensor system for humans. But another approach could be that the devices would just wire into connect to neurons, right? So my question is, how far is development of like cyborgs or connecting, not using eyes, for instance, but wiring?
That's something where I have to be really strict. Mm-hmm. It's related to general system theory that you cannot be, to any system, you cannot be intrusive. You should never ever intrude the system. You have these 5 input channels. We are really far away from utilizing these, like our tip of our finger, like someone gets the visual scene through his tongue. So there's a lot of potential in the senses what we currently have. So we should be thinking about how to use 10 to maximum potential, because there is a strong benefit in doing this, because we have all through our lives, our brain is already learned about getting information through this channel. Now when you intrude the body and put something into your nerves, and say someone sends you an SMS and your brain just goes about, okay, thanks for the message and so on. I would say that respecting the principle of system theory, we should not be
but when you have neuroprosthetics, for instance, you have a hand with a feedback.
Then it's a different story.
It's okay because the man doesn't have a hand.
If you cannot use any other sense, like this guy lost his eye, they used the tongue, and the person could perfectly see through the tongue. So if you lose a hand, can you imagine some other ways using oral feedback or something? You could come up with a lot of different approaches to solve the problem of feedback. More questions?
Yeah, I'm thinking that when you use all the sensory devices that are really technically advanced and so on, then you kind of consuming a lot of energy also. And I'm wondering about the stage of development of replenishing power sources, or maybe something that doesn't use power at all, or something like this, because that's something you have to think of when you're using the real world and as your environment, and then you want to add this layer of input, basically.
I don't know how quickly we can start to build systems which would be self-sustained.
Yeah.
Of course, we are constantly coming up with new solutions. Like we already have clocks which have some inertial metal piece which generates that when you're walking, the clock is
right.
constantly generating energy and is in that way self-sustained. Or just using some solar cells in your baseball hat. I don't know.
Maybe that
about that side.
Like an intrusion kind of way to do it. Like you could possibly generate energy from your nervous system somehow.
Well, I don't think that would be probably the first thing or best source for energy, but for example, if you have an actuator attached to our hand, that like you have LED lights. Okay, this is a little bit silly, but they are in so low in power consumption that you back in the time they had these devices where they could generate the energy. And then we get rid of all that time, and then we have these nice batteries. But now the lamps are in so low power consumption that you can again start to have these mechanical devices to generate a little bit of energy. And you have some sci-fi movies where some systems just work. You just press a button once and it generates enough energy for it to run for 1 day or something. So, but energy problem, I don't know.
Yeah, like the wireless transmission of power, maybe also when you walk around, there might be stuff as you walk past.
Yes, like you have these power keys and all these cell phone charging systems, and so you have something on your bottom of your shoes, and you can hang around in some place and charge your devices while standing on the charging station. Who knows what we could be doing? Okay. And by the way, I have something somewhere. I have one publication, recent publication that I wanted to share to you. If any of these things was interesting, so you can take this publication and maybe read it through. What? You mean that if there's some symptoms, what can be coming because of using this system?
Yeah. For example, on vision, sense, or on the mind. I mean, on memory.
There has to be. There's some. I don't remember exactly now, but there's a very good website where some university. I don't even remember the university, but they are collecting all the virtual and augmented reality research. And they have a good database of what kind of symptoms you have in different kind of scenarios. You use head-mounted display or this kind of tracking system and so on. So, but if you could give me your contact information, so I could probably try to send this link to you.
So you try to follow system design, right? Not
Yes.
to get inside of the system, but communicate using the interfaces.
Yes, what interfaces that are available. Because you never know, like, when you're intruding a system that you can be... Yes.
I'm University of Czechia. I have.
That when you're intruding a system, you never know if you think the system is a black box, that if you are doing some harm, if you are interfering some other unknown things happening, so you can be... I think it's Kevin Barrick who is doing a lot of things, research about this connecting, like Matrix, where you plug in something and then you get to the virtual world and so on. That is violating the system. You should intrude the system.
But it might influence how others communicate through the interfaces,
Yes.
right?
Yeah.
If you wire to these nerves that go to the spine for touch purposes, right? And you try to play with it, then maybe you start touching. And like I'm from India, the Lausanne.
Okay.
And so we have a very huge department in brain powers and already 2 years in neuroprosthetics.
Okay.
So they think like consuming these things, it's really big.
There was this, I think it was Indian researcher, and they had like if you have a like phantom limb that your arms cut,
Oh, yeah.
and maybe you know it, that if you have, for example, pain, that you feel pain on the
but
limb,
there is no
no hand, and his approach was to use mirror. That you put a mirror and you put your other hand. Your brains think that there exists a hand.
Okay.
And for example, by just giving your brain's feedback as if there was a hand, you can move it, and they have done a lot of successful treatments on using this kind of technique. Just to tell the brain the hand is there. They for example, the pain what they experienced during the when the hand got cut away is imprinted in the brain. They feel the pain, but then suddenly they can release the pain, and after that the pain goes away, and the phantom limb doesn't have any pain. So it's like just providing feedback for your brain that don't worry, everything is okay. No, nothing is wrong. So it's quite an interesting. Just €2 mirror, and you solve this kind of problem.
Thank you.
Yeah, thank you.
Thank you for attending.
I really like your bit about the plasticity of the brain and getting used to crazy ways of learning kind of stuff.
Yeah, I was really interested in my part.
Yeah, brilliant.
Really, it was really interesting to see your presentation because there were so many like common points, but I could see what kind of things you are thinking about.
Totally.
So I'm happy to see that these things are getting forward.
Yeah, no, me too, because I mean, you're very technical, so it's very interesting when you talk about the method of loci as well. And I'm like, this is good. This is a really good thing that I get to your talk. So maybe we should collaborate.
Yes,
because,
for sure.
I think we've got a lot of crossovers.
Yeah.
And I like where you're putting this abstract and concrete, putting these two things together. This seems to be really good.
Yeah, it was really a problem for me since I started to work in this field. That I always thought, okay, yes, now I cracked enough. Okay, this is the benefit of virtual and augmented reality. And I always ended up, oh God, no, it's like this again, like modeling these things and modeling benefits. And then eventually these things, this is the things where I ended up. There's something in this in respect to virtual and augmented reality where is the like meaningful thing. So this is
really interesting. I'm going to meet a guy who's also talking about the method of loci and augmented reality next week.
okay.
So it's and I've been trying to get my head around why we should use this as a sort of methodology for using AR, etc. So and it is the sort of mixing of the ancient pedagogy, ancient technology with the modern stuff that seems to be key. So let's talk. So you're just available. You're not on Facebook, are you?
I would sign the group. I didn't sign it so far, but I would sign it.
Okay.
Just for the purpose of
because I use it as a blog and I constantly.
Okay.
It's like my WordPress. I've never got around to getting WordPress. It's kind of like. But yeah, let's. Because I'm constantly going to Sweden, so maybe I can come up to Finland.
Yeah, sure.
Maybe we can write a paper together.
Yeah, indeed.